All right, we talked a little bit about airspace and about charts. Still on the topic of National Airspace System, there are times that new things and changes happen, and that's why they've set up a notices to airmen system. Periodically, frequently, they publish NOTAMs. That's notice to airmen in short. NOTAMs to update information that there's not enough time to put it on a chart or in some kind of other publication. So you get these things from online, or when you call Flight Service Station to get a weather briefing, they will also give you the NOTAMs for whatever area that you are planning to operate. So what I suggest that you do now, you might need to pause the video, but use your phone, do an online search for NOTAM, FAA NOTAM, and you'll get something that looks like that. And you'll have to say, I have read and understood the above statements. It's just a CYA for the feds. But basically, then once you get past that page, you'll have a search thing and search for 6A2, basically Griffin, to find out what changes have happened since they published the chart. And all that's in there right now is something about air traffic control, but then there's a couple of lighted towers where the lights are burned out or something, or new towers. You can read that yourself. And then do another search for maybe something like Reno, RNO, see what's going on out there. Just use your curiosity a little bit to search through these kind of things. But basically, that's your responsibility to check the NOTAMs as a UAV pilot. You are responsible to be aware of any changes in the airspace, especially the existence or the popping up of a temporary flight restriction. Not likely that somebody famous or some politician might visit Griffin, Georgia, but it is possible that that might happen, and there'll be a TFR, temporary flight restriction, which means you cannot fly in that area without authorization from the authorities, which they're not going to give you that if it's somebody famous. They're just protecting airspace for somebody famous or politician, or even some kind of a large event. Like I believe they've had TFRs over the Atlanta Raceway before, but that's your responsibility to check that. Not published, but you go fly into it, they're going to find you, they're going to track you down, and then they're going to take you down, okay? So that's your responsibility to check those things. And those can be checked either online through this system here, the NOTAM search, or you can do a search for TFRs, FAA TFRs. There's several different ways you can get this information, or call Flight Service on the phone. This is another way to do it, is through this graphical TFRs. And you go to this website, and you see where I've searched, TFR search. All right, and it pops up that, you click on that, and then it gives you a map of the whole country, and then there'll be like red circles here and there, and then you can zoom in on that, and it'll be a TFR, and you'll see, if you zoom in there, you'll see one around the Capitol building in Washington, D.C., and you'll see one down over Disney World in Florida. Right, the one at Disney World is semi-permanent, but mostly and the one over Washington, D.C. is permanent, but in other places they'll just pop up seemingly at random, but they are associated with some event or some security issue with a politician or somebody famous. Or there was some in Florida when that building collapsed down in South Florida. They simply put that up there because so many curious drone flyers were buzzing around. They were taking pictures of the collapsed building that the rescue helicopters and the fire department were nervous about all these drones flying around. So, and other airplanes, it wasn't just drones, but manned aircraft were buzzing around just wanting to take pictures as well. So it's not just because of drones, just to clear the airspace. The fires out west, sometimes they'll put TFRs out there because they've got these fire airplanes that dump fire retardant chemicals on top of the forest fires. We have different kinds of NOTAMs. FDC NOTAMs are pretty specific. They're issued to designate those temporary flight restriction areas. And the NOTAM, if you're going to read them digitally, if you call them on the phone and ask, they'll tell you verbally. But if you're going to read them, they'll start with the phrase flight restrictions, followed by the location, effective time periods, the area covered, and the altitude of the restriction. NODAM will also contain the issuing facility with the phone number. The reason for the restriction of the information is necessary. TFR always excludes UAV operation. One way or the other, its remote pilot and commands are responsible for checking any NOTAMs that may affect their intended flight. Other resources that we have to give us information about the National Airspace System and about aviation in general. These are called advisory circulars, and they are the FAA's interpretation and expansion of our understanding of the regulations. Okay, so they expand. They don't add regulation, but they expand on how we might understand them and how we might operate in these under those restrictions, under those regulations. So we have a lot of different. We have tons of them, many advisory circulars for different topics as well. For icing, for weather, there's weather circulars. Some of them are very lengthy books. The weather. Where is it here? There's aviation weather. This is published as an AC. It's an advisory circular 00-6, and right now it's B, but that changes. They give revisions occasionally, so they'll add an extra letter, but advisory circular 00-6 is something about aviation weather. So these are sources of information. Then we have the Airman's Information Manual, which is very similar, except it's sort of established as like, these are the best practices. That's probably the best way to put it. It's best practices for aviation, for airmen specifically. So this is where you'll find out about traffic patterns, where the terminology for traffic patterns, terminology for radio communication, we have those patterns where we say things in certain order so that it'd be easier to communicate over a radio that's scratchy and noisy and all that. This is where we find that kind of information. We find the information about how to communicate to air traffic controllers and how they communicate to us. And there's a lot of things. The airport lighting systems, information about chart reading as well. A lot of information about that as well. The official statement is the AIM, or the Airman's Information Manual, is the official guide to basic flight information and ATC procedures, issued yearly with revisions during the year when needed. So ACs and the Airman's Information Manual should be regularly checked for updates and revisions. Both of them, of these publications, are available online, so really don't need to purchase hard copies. You can if you want to, but we should be, as lifelong learners, again, we should possess curiosity about the operations, so we should be reading this kind of stuff and keeping up with the updates. Additional information is the Chart Supplement US. You might want to pause the video now and do a search for it, but just a second. Chart Supplement US is basically additional information about specific airports that would not fit on the sectional chart. Runway lengths, a lot of information about this. I'll probably need to do a separate video to explain this, and but for now we'll move on. You just do a search, just for your curiosity, do a search for Chart Supplement US. You come up with some kind of form like this. Search by airport identifier, so put 6A2, and you'll see a lot more information about the Griffin-Spalding County Airport. The airport manager's phone number, one of the things you got. I wouldn't suggest calling him in the middle of the night, but if you have a question about the airport, that's who you would call. But you'd also have numbers for, you find a phone number to get the automated weather. It's constantly recorded from their automated weather system. There's runway lengths, runway numbers, latitude, longitude, location of the actual airport, whether or not they have fuel or not. A lot of information, way more than you could possibly find on the chart. So I suggest you do that. We're going to go to the next slide, and we're going to talk briefly, or I'm going to talk briefly about latitude and longitude. So pause this video and do a little search, use your curiosity a little bit, search for different airports, and see if you can't understand some of what's being said.
In preparation for the FAA Part 107 knowledge exam, they will ask you about latitude and longitude. All right, latitude and longitude. The definition, of course, is it's a global address system for locating any spot on the planet. Latitude and longitude lines are depicted on the sectional chart, and they will ask you conceptual questions about what is latitude, longitude, what's the difference between latitude and longitude, but then they'll ask specific questions about finding a location or what latitude, longitude coordinate is a particular airport, and we'll cover that in a second. But first off, let's discuss latitude. Latitude lines are horizontal mapping lines. They're known as parallels of latitude because they are parallel to the equator. So the equator is 0 latitude. You might imagine this as big hula hoops. At the equator, they're the biggest hula hoop. And as you move northward, or if you move southward, they get smaller all the way up. So anything north of the equator is a northern latitude, and everything south of the equator would be southern or south latitude. All right, they're stacked up. These hula hoops are stacked up smaller and smaller and smaller until they get to the North Pole or the South Pole, to the poles, and then they're one spot. Then there's longitude lines. Longitude lines are vertical mapping lines on the Earth, otherwise known as meridians. One simple way to think about it is a hula hoop cut in half, vertically positioned with one end at the North Pole and the other at the South Pole. So longitude lines are a numerical way to measure how far a location is east or west of the universal vertical line called the prime meridian. That prime meridian, of course, is located at the British Royal Observatory in Greenwich, England. And they run from the North Pole to the South Pole. The prime meridian in Greenwich, England is 0. To measure a longitude east or west of the prime meridian, there's 180 degrees or 180 vertical longitude lines east of the prime meridian and 180 degree vertical longitude lines west of the prime meridian. So longitude locations are given as, 90 degrees east or 90 degrees west, or 84 degrees east, 84 west. The 180 degree line is a single vertical line called the international date line, the opposite end of the planet, right? It's directly opposite of the prime meridian. So that's the basic idea. The other specific questions they might ask is, refer to a figure in the booklet, refer to figure 26. What does the lines of latitude and area 4 measure? Well, they're not asking you to find something, they're just asking you, what is it measuring? Well, lines of latitude always measure degrees north or south of the equator. Right, latitude is like a big hula hoop that goes around the equator. They get smaller as you go further north. They go smaller as you get further south of the equator. So that makes total sense. What does the lines of latitude in area 4 measure? So they're asking you a general question. You can look it up on the figure 26 if you want, but you know that lines of latitude measure. The answers are lines of latitude east and west of the prime meridian? No. Lines of latitude are north and south of the equator. Another question they might give you would be, which statement is true about longitude and latitude? And they're basically giving you 2 wrong answers and giving you a correct answer, or the best answer. The best answer, of course, lines of longitude cross the equator at right angles. All right, so the longitude are from the North Pole to the South Pole at Greenwich, England. That's it. Another set of kinds of questions they'll ask you is, what airport is located approximately 47 degrees, 40 minutes north latitude and 101 degrees, 26 minutes west longitude? So they're asking to look at a figure 21, and they're trying to find the nearest airport to that location. So now you got to look at the edge of the chart, find that. First off, you have to know the difference between latitude and longitude, so you're looking at the correct line, and then to find the location. Another question would be opposite. They give you an airport, and they give you an airport, and then they tell you, or they ask you, what is the latitude? What's the latitude and longitude location of that particular airport? So you have to find the airport on the little chart excerpt, then figure out where the longitude and latitudes are. So that's basically what's going to be on the test, those kind of questions. Not a massive amount of them, and it's not that complicated, but you do need to sit back and go look at the chart, find a sectional chart. You've got the link there to find a chart, and you've got the booklet as well, and try to find the markings and try to understand that.
So here here's basically latitude, longitude lines. It's just a grid pattern to find locations, basically. And it's not just planet Earth, it's the moon, it's Mars, all of them are geographic locations are determined through a system, some kind of grid system, basically, to find a location. So anyway, I thought that fellow did a pretty good job of describing it. But if certainly contact me if you still have some confusion about this, because there will be some questions on that, and they can really baffle you if you're not somewhat familiar with the concept. Oh, by the way, that is the actual prime meridian. That's in England, and you can see they're saying Los Angeles is 118 degrees, 15 minutes west. That way, basically that way, of the prime meridian. This would be in the prime meridian here. Tokyo is 139 degrees, 45 minutes east, that way. So next time you go to England, you need to go to Greenwich, and you need to stand here so you can say that I'm in both hemispheres at the same time. Yeah, big deal. Okay, back to the chart. Just to remind you what we're looking for, these are the numbers over here on the side. Here's 36 degrees north. That's that line that goes this way, 36 degrees north. And let's see if I can't find a, yeah, here it is right here, 87. It's sort of hard to see. That's 87 degrees west. All right, you have to just have a basic understanding of geography to get the west part. It doesn't say W, and it doesn't say 36 north either, but I mean, you know where the equator is down that way, and you know where east and west is, but that's basically, and these little markings here, well, that's another catch here you can get messed up with. 36, so here's 30 degrees. If 0 is down here at the equator, then this is 35 minutes and 30 seconds. 35 minutes, 30 seconds, right? Because you're counting up. 35, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. There's 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. There's 50. And then there's 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. There is 60 degrees between 35 and 36 degrees. There's 60 minutes. The same with this way. Between 87 and 88, here's 88 and there's 87. Between those two, there are 60 minutes. This one here, you only get 30 minutes between here and there because I zoomed into the chart so you can read it. This is 30 minutes. But it's 60 minutes all the way down to 35. I hope that is understandable. So the question might be asked to you on a test, what's the approximate latitude longitude for M15 Tucker? which is an uncontrolled airport. Let's see if I can't find it. Tucker. There it is right there. There's Tucker. Okay, so we know that this is 3530, 3531, 32, 33, 34, 35, 36, 36. No, don't do that. 36. Don't end the show. Oh, phooey. No. Okay, good. So that's 1, 2, 3, 4, 5, 6, 36. So that's 35, 36. Right? That line across there is 35, 36 north. And then you go to find the line that goes this way. That's got to be, there's 87. 87, and there's 88. Well, you can almost guess it's about halfway. So 87 and 33, something like that. 87 degrees and 33 minutes. That would be the location. That'd be the answer to the question. Of course, it's a multiple choice question, so one of them is going to be crazy. It's going to be, and of course, this is west. So the answers will be, one of the answers will be 87 87 degrees, 33 minutes east. Well, we can scratch that one off because no, he ain't. If this is America, it ain't east of the prime meridian. It's west of the prime meridian. That's the kind of thing that it'll do. So they're not going to ask for this little minute thing. You want to get pretty close, but you don't need to be so precise as you spend 45 minutes trying to answer this question. This is, again, it's going to be on a computer screen, most likely. I don't think they do actual paper tests anymore. Maybe they do in this particular location where you take the test, but okay. So you want to land in a specific place on the moon? It'll be something similar to this. So good luck with that. Again, ask questions if you don't understand. All right, here's multiple items in here that we're going to just take a look at. We've talked about these obstructions, right, already, right? This is mean sea level. This is above ground level. We've talked about, we haven't talked much about MOAs, military operating areas. That's just, and I can't see any borders here, so this is not a very good example of military operating areas, but that's what they're saying, is this whole area will be bounded by a border that'll give indications about that. Let's see, that just means the military operating, it could be low, high-speed aircraft. Military operating areas, all aircraft, all manned aircraft below 10,000 feet are limited to 250 knots, maximum speed, because just for the purpose of helping air traffic controllers, but also to give you a little more time before you bump into something. But the military guys, they need to be able to fly faster in some areas, so they have these separate airspaces all over the country called military operating areas. And these guys can buzz around at faster speeds than normally would be allowed. And that becomes a hazard. Not only faster speeds, but also lower altitudes. These are contour lines where it says 4,000 feet here. That's a contour line. It says the top of this hill, or that contour line right here is at the 4,000 foot layer, actually. See, it goes squiggly line. I'm not sure I'm totally accurate, but all that is 4,000 feet. That's just the contour line that divides. I'm not sure I got that right, but right. So they have different ones: 2,500, 3,000 foot. Then we have spots here. A spot means that's the top of that particular hill. Is the maximum altitude of that hill is 4,700 feet. So they could be flying very low over the top of that thing. By the way, let's say you're at this top of this mountain. I don't know what's there. How high can you fly your UAV? You fly 400 feet. It's the maximum altitude you can fly over it. 400 feet AGL, but 400 feet AGL is 5,200 feet. So you're actually flying 5,200 feet MSL. Just for grins, I just brought that up. That does have an application because that's pretty thin air, right? Your drone's not going to behave as well at that altitude than it was at sea level or in Griffin. Let's see, we have another one. We have IR-82. Remember, that is a military training route. We have that may be active when the weather's not that good. 82 means it's above 1,500 feet. Do I see another one? No, I don't see another military training route there. MOU, by the way, I cut off mountain, so they're just saying Appalachian Mountains there, so don't get freaked out about that. That has no meaning. It's just a designation of what kind of hill it was. Beechertown. Let's find Beechertown. Beechertown. See okay, right there. What is this? If you had been curious about your sectional charts, you would have known it's just a transmission tower, wires. There's 6,600 feet. That just tells you that's just for manned aircraft, basically telling them that you get much lower than that, you're in danger of hitting something. So don't go any lower than that in this area. It's a maximum elevation figure. Shows the highest obstacle within the grid line, plus 200 feet for things that might not be mapped, plus another 100 feet for vertical error, and rounded up to the nearest 100 feet. So a lot of other information on the chart here. Highways, the little yellow area here just is a populated area, basically. This is populated area, this is sparsely populated area over here. All that other area. I could ask you, why is this colored magenta? And hopefully you would say it's an uncontrolled airport. I could ask you many questions, though I won't. Okay, so next week we're going to start going into aviation weather. So there is a book. I showed it to you here. Aviation weather. This, again, you can spend a bunch of money and buy this book, or you can download it free from the FAA. So you might want to start looking through that book. Like I said, aviation has a very small margin for error, and so there is a lot of information we can learn and understand. It seems obvious to you right now to look out the window. It looks like a good day. I'm going to go flying, but there's more to it than that. And definitely for the written test, there's more to it than that. Yes. You're probably not going to go wrong by looking out the window and saying this is a good day to fly, and if the weather starts getting bad, you land right away. Cool. But the FAA wants you to know more about that. The FAA, again, considers you a pilot. You're not a junior pilot. You're not a fake pilot. You're a real pilot. And if you're a real pilot, you need to know pilot stuff. So if you have time, look through aviation weather. There's a lot more that you really want to know in there, perhaps, but there's some good stuff. You need to pull that stuff out. We will be talking next week. We'll begin to get into that information. All right, hang in there. Good night.